Again, thank you very much, and good afternoon, everyone. So I will talk about the analog RF digital interface, it is a topic that recently has attracted even more attention. So I will, in a way, I will present a holistic view, if you will, of the analog RF digital interface, and I will make some connections to ontology descriptions that I think are closely related. So here's a kind of a short outline of my talk. So the first topic is, how can we make this analog RF digital interface open? And what does it mean to be open? I still think that the word open, as much as everyone likes it, I think the meaning of that word can be different. In particular, I will present one not very well-known standard called VITA 49, which, in my opinion, does achieve accomplishes the goal of making this interface to be really open, where one side doesn't know anything and doesn't assume anything about the other side. And then I will talk about how can this standard be extended. So what is the evolution that, according to me, what is the evolution of this standard, and why does it make sense to the standard to evolve? So I will talk about new packet types, and I will see I will see what can be accomplished using this standard. So I'll talk about tasks, policies, and a new type of a services discovery protocol. Then I will make the connection with ontologies, and in fact, we'll see that ontologies and metadata, which I will introduce right now, ontologies and metadata, they go hand in hand. So whenever you have one, you kind of automatically, I would say, or automatically have the other one, and you're very close. And then I will try to identify some directions for future research. So first is, well, what is it really software-defined architecture in the radio space? And this is, I mean, this is one relatively, I mean, it's an old figure, but it says this is how a number of people have continued to view software-defined radio architectures. And well, if we subscribe to this architecture, the question is, where is the analog RF digital interface here in this picture? And yes, I'm aware people will point to the data aspect, right? There is a lot of data that's being exchanged, but that is not really what is the bottleneck here. The reason is that without context, which for me is context is synonymous with metadata. And without that context, data is really meaningless, right? You have a lot of data, but you don't know the context, then essentially you don't know what to do with this data. And the metadata is really the bottleneck. And it is the metadata part that, because it is a bottleneck, has generally not been implemented in an interoperable way. And everybody is focusing on the data aspect, which is not that difficult to implement. So, and now I will talk about the standard VITA 49. First, this standard was limited only to receivers. So the history is a little more than 10 years old here, initially limited to only to receivers. But then it was very quickly extended to both receivers and transmitters. So for really different applications than uh, uh, more for signal intelligence applications. So this is an interface, and that's why it's part of the VITA family of standards. So it emerged because the software-defined radio philosophy requires independence between the hardware and the software, real independence. And where, as I said, where one side assumes nothing about the other side. And if you start making a lot of assumptions, then I would argue that that's not really an open interface. And now you start closing it, even if the other side comes from a different vendor, as long as there are a number of assumptions on the other side, then, as I said, it's not really open. And so I regard VITA 49 as the litmus test if an architecture is software defined. And this vision has not really being achieved because the easy problems have been addressed, but the more difficult problems have, in general, not been addressed, although some attempts and some solutions do exist. So this is a standard that, from a high-level perspective, is really simple. It includes packets. Packets are being exchanged over this interface, and some packets are data, and some packets are metadata. Metadata is a very small percentage here of the overall packets, but a very important part of the interface. This metadata is being extended, so there are control packets, there are some other packet types to provide flexibility, but from a basic perspective, this is what the standard is. So how can VITA 49.2 be extended? And so we envision this to be really a language for the description of the RF environment and really anything that is related to the RF environment. So now some of the types of descriptions that we have developed are we have developed the transmit task. So a description of the task together with specifying all necessary aspects of this task, such as waveform, start time, etc., and all parameters of that waveform. Another task that we have given the standard is the sensing task. And it's really a subset of the receive task, but it's a specialized task that requires its own description. The other aspects in which we have extended it is describing the hardware and software. And these descriptions are really extensible, so it's not like one complete description, but it's a description that can be extended at any time. So existing applications, they ignore what they don't understand, and they process only what they understand. So they don't need to be upgraded when additional descriptions are added. Another aspect in which we have extended the standard is describing policy and policy parameters and policies of policies. So now we also we have defined some new packet types. One packet type is like a capabilities packet. which can be sent in response to a request. It can be sent on its own, and it's not associated with any data. So it could be sent by either subsystem. So essentially describing the capabilities of that system. And a task is yet another new packet type. One task is to reconfigure a subsystem. And but the capabilities and the tasks, they are related because a task should not be given to a subsystem if that subsystem is not capable of performing that task. So first we need to know what are its capabilities before we give it a task. So I would here ask some questions about extending this idea and about relationship to other developments, because I'm aware that there are a number of related developments here. So one question is, how do you store RF data? Right? I don't know how many have encountered this problem, but if you have to just store RF data, how do you do it? And well, VITA 49 does provide a solution for that, and it gives you packets. But the packet structure by itself is not a big overhead. Another solution is these packets can be processed to remove that overhead. But even as packets, we have found that that's not a big overhead. Now, a different format is possible, but obviously we need to convert to and from different formats. And another question that I want to ask is that the metadata, this is what we have observed, the metadata in the form of context, capabilities, that needs to propagate to various software applications. And this has become a critical bottleneck, critical aspect for extending these capabilities. And right now, maybe it's not that well known because these developments, because the metadata has not yet propagated to the different software applications. And only when it propagates, it becomes a lot more useful. So its usefulness will increase. And so we envision a number of subsystems that can generate metadata of their own, and that metadata also can propagate to other software applications. So now, how do we integrate data and metadata produced by different platforms? Now, obviously, the classical conversion problem is, well, is 0102, is that January 2nd to February 1st, but that is a trivial problem. Now, converting between different metadata representations is not always straightforward, right? And even frequency can have different meanings. And something that we have worked on and that we envision is that a neural network can be used, and this neural network gives a representation of the data as seen by a different standard if necessary. So this neural network accomplishes the conversion standard. And now beyond this neural network, we do envision some other machine learning algorithms which can convert the metadata format from one to another. And so these machine learning algorithms can be considered as part of the interface. So I mentioned about policies, and what is a policy here? So it's again at the high level. There's a policy is a set of rules, and the rules contain some actions and some parameters, and it's addressed to a group of devices. So we have a number of policies, including policy of policies. And so this is one picture here of roughly what I'm talking about. So we see here streams. We see streams of data and streams of associated metadata. There are also streams of metadata that is not necessarily associated with the data, streams of tasks, and the way that I described, streams also of policies. Policies are described in this way. And these streams are exchanged between RF clients. I prefer to call them clients, and some on the other end, there's some clouds. Now, I would also mention that, well, what is closely related, seems to me, is the open radio access networks, right? Which, for which there are several ways they can be made open. So if we look at the cellular protocol architecture, right, the first question is at which layer do we, how do we partition this architecture? And I think this is a very closely related development. But still, I think even after partitioning, one side makes usually a number of assumptions about the other side. Finally, we envision a comprehensive ontology describing the communication, networking, devices, policy, tasks, and protocols. And so some new capabilities are just the ability to answer questions such as what devices and what capabilities are available. And so leading to RF data analytics and sensor fusion techniques. So some of the future work directions, we envision extending this standard, building a services discovery protocol on the basis of the standard, and further ontology work, and developing algorithms that are becoming part of the interface. So with this, thank you very much.